Okay, now for polyhydric alkanol, like I explained earlier on, they are alkanols that contain more than one OH group, more than one hydroxyl group. Consider the table below and see examples. All right, from the table below, you can see alkanol example and the structure. Example of polyhydric alkanol. I told us polyhydric alkanols are divided into dihydric alkanols and trihydric alkanols. And dihydric alkanols are alkanols with two OH group, while trihydric alkanols are alkanols with three OH groups. Now look at the structure. Look at the structure. Um, you have ethane 1,2-diol. Okay. Look at the structure. Ethene 1,2-diol. Can you see 1, 2? If you count the first carbon 1, the second one 2. Ethane 1,2-diol, ethylene glycol. That's the other name for it. Don't want to get into naming proper. You get the analysis of all this. Then trihydric alcohol, propane 1,2-triol, also called glycerol. You can see the three hydroxyl groups bonded to the carbon atoms. All right, quickly, physical properties of alkanols. Physical properties. The lower members are colorless with distinctive odor, yes, and a burning taste. Okay, then solubility. Okay, the lower members are highly soluble in water. Yes, another jump question you have here. The lower members are highly soluble in water. Why? Jam normally ask this kind of question due to the presence of the hydroxyl group, but the solubility decreases as the homologous series ascends due to increase in molecular weight. What does that mean? It simply means that the solubility of the alkanol series they decrease as the as the number of carbon atoms increase. Are you getting it? As the number of carbon atoms increases. Okay, the melting point. The simple alkanols have low melting points, and the boiling points are considerably higher than those of the alkanes. Another question you have here: their boiling points are considerably higher than those of the alkanes because of the presence of hydrogen bonding between the hydroxyl group. That means, for example, methanol has an higher boiling point than methane. Just the same way ethanol has a higher boiling point than ethane. All right. So quickly, the chemical properties of alkanols. Number one, they react with metals. When alkanols react with metals, what is formed? You have sodium. Okay, for example, sodium. You have sodium alkoxide. That alkoxide is gotten from alkyl and oxygen. So the only thing that combines, look at it, RONA plus H2. So you have sodium alkyl oxide. So when methanol reacts with sodium, you have sodium methoxide and hydrogen. When ethanol reacts with sodium, you have sodium ethoxide and hydrogen. You have sodium ethoxide and hydrogen. Can you see the only thing that sodium displaces hydrogen? Okay, I think this is an example of a displacement reaction. Sodium displaces hydrogen. Why? We all know the reason. It is higher than hydrogen in the electrochemical series. It is higher than hydrogen in the electrochemical series. So it displaces hydrogen, and also another reason is because it is more electropositive than hydrogen.